Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. Today's challenge is basically a typical problem of DP on grids. Okay, if you are following my DP playlist already, so this question should be doable to you quite. Okay, if not, then definitely continue watching the video. And I would like you to say that I have started my DP playlist. Okay, I am not giving videos for last 2 weeks. Okay, but I will soon start giving more videos in it. Okay, you can definitely follow this. And this for watching this video, I will suggest you to go through this problem, code 64, which is minimum path sum, which is in my DP playlist problem video number 7. Okay, so definitely you should go through this video first. Link is also in the description because it is quite a related problem. Okay, and the foundation of DP on grids of finding the minimum path or the maximum path is something like this only. Okay, so you should definitely have done Leetcode 64. Okay, so definitely the prerequisite for this is Leetcode 64. Even if you have not done this problem, I will try to give you an idea of how what exactly this question is, and then only I will start moving to the next question. Okay, so in this question you are given a grade. Okay, in this question what basically happens that you are given a grade, and you have some cost. Okay, every cell has some cost. Let's say this is 1, this 2, this 3, this 6, something like this. These all have some cost, and you want to reach from this cell. You are currently in this cell and you want to reach this cell. Okay, so from 0 comma 0 you want to reach somewhere n minus 1 comma n minus 1, and you are asked to find a minimum path sum. Okay, so what path will you take? You should tell me the minimum value, and you are only allowed to move in this manner. Okay, so these are only the ways in which you are allowed to move, and maybe I guess this manner also. So whatever be the case, you just look at it, how you are allowed to move. So if you are in this grid, you can only move to this. And so if that is the case, what will happen if you see, or if you are allowed to move, let's take three directions in which you are allowed to move. So if you are in a particular grid, this, okay, I comma j, from where would you have come? You could have come from this, which is nothing but I minus 1 comma j. You could have also have come from this, which is nothing but I j minus 1. Okay, this is nothing but I j minus 1, and you could also have come from I minus 1 j minus 1. So what we do in this is that we basically create a DP table. We do DP equals to grids. Okay, so we initialize the DP as grids, and we just go through all the cells and do apply this formula. I hope you understand this. Out of all the three possibilities of every cell, which is giving me the minimum path that I will take. So it gives me nothing like something like dp of I minus 1 j minus 1 dp of, okay, so if I'm finding the minimum path, I will take the minimum among all of these, dp of I j minus 1 and dp of I minus 1 j. So these are the paths from which I will take, and definitely I will have the grid value currently also. Okay, so grid ij will definitely be added to my answer, and this will be equal to nothing but the dp value. So this is something how you do the DP on grid solution. Okay, so this is the Leetcode 64. You just go and check it out. Okay, this is definitely a prerequisite for this problem. If you are directly solving this problem of today's daily challenge without solving this question, without knowing anything about this question, it just doesn't make any sense. Okay, just it doesn't make any sense. So I just told you an idea of what exactly is the problem, and how you should approach it, so that I can just continue with today's daily challenge on Leetcode. So let's try to read the problem first. Find the maximum number of fruits collected. There is a game dungeon comprising of n cross n rooms. Okay, so you're given an n cross n grids, and each grid has some fruits. Okay, fruits ij. It is given by fruits ij, and there are three children which will play. One of the children is at 0 comma 0, another is at 0 comma n minus 1, and another is at n minus 1 comma 0. So what is the case here is that you are having a grid. Let's make a 5 cross 5 grid. Okay, for better understanding, let's make a 5 cross 5 grid. it is given that the grid will always be n cross n, and you will have three children. One children is starting from here, one is starting from here, one is starting from here. All of them have to reach this point. Okay, this has to reach this point, this has to reach this point, this has to reach the last point. Last cell is the goal. Okay, you need to reach here in n minus 1 steps. Okay, in n minus 1 steps. And it is also given that the child starting at 0 comma 0 must move their current room to one of these rooms. Okay, so it is just given the what are the transition paths. Okay, so what does this mean basically is that this child, at every step it has three choices to move: this and this. Okay, so let me do it in some different color. So this child has three choices to move. Okay, and this child also has three choices to move. Okay, and this child also has three choices to move. So these are the choices in which they can move. And it goes without saying that definitely they cannot move out of the grid. So that's quite obvious. And these are, and they must reach the goal. So there is an additional criteria is that reach the goal. Okay, reach the goal in n minus 1 steps. Okay, so n minus 1 steps is the maximum number of steps, is the exact number of steps which you can take to reach the goal. Okay, so as you can see, uh, if you talk about this guy, okay, so let's talk about this guy at first. If you are talking about this guy, you see how many choices does it have? If let's say it goes from here, okay, then let's say it goes here, one, two, and let's say this is a 5 cross 5 grid. Okay, so it must reach in 4 steps, n minus 1 step. And then let's say it go here, and let's say then it goes here, and let's say then it goes here. Okay, and it is also given that in whichever grid you go, you collect all the fruits. Okay, so you just collect all the fruits, and you want to maximize the number of fruits collected by all the three children. Okay, so in the problem in which I was talking about earlier is that there is only one children and it wants to go from start to end. Okay, but here are just three children, and you just need to maximize the count of all of the fruits. Okay, all of the fruits collected by them. So you see how many steps you took. Okay, so for this guy you just took this number of steps. This is one step, this is two steps, this is three, this is four, this is five, but you had to complete in 4 steps. So can you tell me why did this happen? So it happened because you did not follow the optimal path. So can you is it now obvious to you that this guy on the point of 0 comma 0 has only one choice at every step, that is it will go straight. It will just go along the diagonal straight, collecting every fruit. Okay, it will just go along the diagonal and it will collect all of the fruits, and it will just give you the answer. Okay, so I hope you understand this, because if it tries to move away from the diagonal at any point, if it moves away from the diagonal, it will end up in taking more number of steps to reach the end point, and which will be more than n minus 1. So you see how many, this is the moving along the diagonal is the most optimal path. And what is the number of steps in the most optimal path? You count, this is one step, this is two steps, this is three steps, this is four steps. So if the number of steps required to reach the end point from the starting point is n minus 1, and that is the maximum number of steps you can take, then it implies that you have only one choice. So this guy standing at 0 comma 0 has only one choice of reaching the end. Okay, and it will end up in collecting all of the candies which is at the diagonal. Okay, so I hope you understand this. So let me just quickly do one thing. I will just at first collect all the fruits along the diagonal. So that is very obvious and intuitive also, I guess. So I will just collect everything along the diagonal. I will just go from I equals to 0 to n, and I will just add everything to my answer, which means that I will just add fruits of I. Okay, so I just added fruits of I to my answer. So I hope that is very intuitive and simple to you, because we need to add all the fruits by all the children, and the first children is having only one choice of path. So I just trivially add all of those choices. So that's what I did. Okay, so now can you tell me one thing? Can you tell me another observation by doing that? What are the constraints for this guy who is standing at 0 comma n minus 1? Okay, what are the constraints of this guy? The first thing which you can observe is that if you are able to solve for this guy, this 0 comma n minus 1, then solving for this n minus 1 comma 0 is also very trivial. What will you do? you can just flip the matrices. If you see, this is just if you just take a transpose of the whole matrix, if you just take a transpose of the whole matrix, then what will remain? What will remain is that this guy will move there, okay, and this guy will move here, and whatever you did with this guy 0 comma n minus 1 guy, you can also do the same operation with 0 comma n minus 1 comma 0 guy, and whatever answer you just got there, you just run the same function and you will get again answer. So first observation is that, first observation and very simple observation is that, if you solve for this 0 comma n minus 1 guy, okay, then you uh, can easily solve the other case also, can easily solve the other case also by taking transpose of the matrix, okay, taking transpose, okay, by taking simple transpose. So I hope first observation is very clear and easy for you. Okay, now what is the second observation? uh, this guy who is coming from 0 comma n minus 1 cannot cross the midpoint of the grid, okay, cannot cross this diagonal line. If it ever crosses, it cannot reach in n minus 1 steps, okay. So I hope you can easily understand that, okay. So uh, let's say it cannot step on the diagonal also, because once it steps on the diagonal, the only optimal path is to traverse along the diagonal, okay, and there is no use of overlapping the same path which has already been taken, because you will end up in taking less number of fruits, because those fruits are already collected. You cannot collect them twice, okay. So what is the optimal for the 0 comma n minus 1 guy is that, uh, this is by observation, is that for the 0 comma n minus 1 guy, it cannot it cannot touch the diagonal line, touch or cross, okay, both. Without touching also you can cross it. uh, so you can just imagine, okay, you can just draw and just draw it on your copy, and so just understand how you can touch, how you can cross without touching. So whatever be the case, I'm just telling that it cannot touch or cross the diagonal line. Okay, so this is another observation. I hope these two observations are pretty straightforward and pretty clear to you. Okay, I guess anyone will understand. Anyone should understand these two observations at least. Even if it does not click in your mind, definitely I hope you now get it. So all you need to focus in this upper triangular matrix. Okay, so all your focus should be in this upper triangular matrix, and you want to make this guy reach its home. Okay, and what are the possible cases? If you see this simulation, if you try to see this red, okay, you see the red path. First it is in 4, it goes to 8, then it goes to 12, and then it goes to 1. Okay, so now another thing, uh this for the same guy, you need to reach you need to reach n minus 2 comma n minus 1, not n minus 1 comma n minus 1. Can you tell me why? Because once you reach this point, okay, because let's say you are having some grid, uh, okay, you are having some grid, and once you, in any shape, grid on any shape, this guy is already traveling along the diagonal, right? One guy is already traveling along the diagonal, so you do not want to touch the diagonal. So if you reach this point, from this point you have only one choice, to go here, and you will not get any fruits in that, because this is already collected by the first guy. So instead of trying to reach this, I will just focus that this 0 comma n minus 1 guy is trying to reach this cell, okay. So it is trying to reach this cell, and as I had done here, as I had done something in this Leetcode 64, I will do a similar thing here. I will ask you that what are the possible choices, okay. So if a guy is standing here, what are the possible choices it could have come from? It could have come from here, it could have come from here, it could have come from here, and definitely we will take care of things like it could not come from somewhere outside the grid. And if it comes from anywhere here or here, we will just select the one with the maximum value. Okay, so among all these values, so let's say we are in some I comma j point. Okay, we are in some I comma j point. Definitely, for being in the upper triangular matrix, j needs to be greater than I hope you understand that, and not touching the diagonal also. And another thing is that for I comma j, you could have taken the steps from I minus 1 j. You could have taken the steps from I minus 1 j minus 1. You could have taken the steps from I minus 1 j plus 1. So you see everywhere it's I minus 1 only. So this does means that if you are at this point I comma j, okay, you could have taken from this, from this, from this. So this is nothing but this is all belonging to the same row. Okay, this is the I minus 1 row, but this is j minus 1, this is j, and this is j plus 1. Out of all these three choices, you need to tell me that which are valid, and need to tell me the maximum value. You need to calculate the maximum in a very similar manner of dp on grids. Okay, so I hope you understand this. In a very similar manner, you will just do is you will just tell me that which path is the maximum. Okay, so I will just try to code it out quickly. So I will just write a function which will calculate a maximum score. Okay, so it will just give me maximum score, and the input will be very simple. It will be just a simple fruits, and you will have a dp also. Let's have a 2d dp also, and let me initialize it to n. Okay, so let's have this fruit dot size also. It's an n cross n grid, if you remember. So this dp will also have something like n cross n. Okay, and I will just initialize this dp to all the values in the fruits. And now what I should do, what I should do. Okay, so I should go from I already told you that I'm traversing backwards. So I am traversing backwards from I'm starting from this point. Okay, so I'm starting from somewhere this point. Okay, I'm starting from this point, and if you try to see, I will again go. So I'm starting from I equals to n minus 2. Okay, I equals to n minus 2, and I need to go here or here? You see, I do not need to go, because you see, when I am first of all, you need to notice this thing very carefully. So I am again drawing another grid. So let me draw a pretty large grid this time. Okay, so that you understand very easily what are the ranges of traversal, because that becomes very I mean, that is the very important part, and that's what makes this problem from a medium to hard one. Okay, so uh, you see, you need to reach this point, right? Because from this, there is only one way to move here, and you are currently here. Okay, you are currently here. So from this, I have told you that every possible point, I will just take care that I can move from this, or this. Okay, but from this, I mean, from this, you can move only to two squares, right? So if you are here, you can just move from, you have just only one choice. And if you are here, you have also just one choice. So what can you do? What can you do for, like, I mean to say that when you are in this grid, you cannot tell me that I come from here, here, or here. Okay, but that's because in initial starting point is only this. So what you do is that you calculate till this. Okay, from n minus 2 n minus 1. Okay, you calculate 1 n minus 1, and when you are in the I n minus 1, you are already taking care of what is there in I minus 1 n minus 1. Okay, how we are taking care of that, I told you already. I minus 1 j, I minus 1, you are taking care of I minus 1 j plus 1, and I minus 1 j minus 1. Okay, so I minus 1 case you are already taking care of when you are at the I. So I will move from n equals I equals to n minus 2 to I greater than 1. Okay, I hope you easily get this. So let's move from I equals to n minus 2 to somewhere I greater than 1, and I will moving backwards. Okay, I'm moving backwards, and I will also have a j. Okay, now j will only move after the diagonal. So I do not want to touch the diagonal, right? This is my diagonal line, and I do not want to touch it. So this is I equal to j, right? So this is the case where j is greater than I. So let me say that j starts from I plus 1 and goes to j less than n. Okay, so j is moving in this manner. Okay, and I is moving from top to bottom to top. So K can easily move from somewhere like I plus 1 to j less than n j plus plus. I hope you get it easily. Okay, so yeah, that's now quite simple. Now I want to take a step. Okay, now easily you can understand that I minus 1, j minus 1. What are the possible steps from I comma j? From I comma j, okay. So what are the possible steps which you can take from I comma j? So you can go to I minus 1, j minus 1, I minus 1, j, and also I minus 1, j plus 1, okay. So you have an x. Let's say that x is I minus 1, okay, and you have a y also, which is the j value, but j goes from j minus y goes from j minus 1 to j plus 1, right? So I will have another loop of size 3 only, okay. So this will take the values of j. So uh, let me do it from j plus 1 and y plus plus. So it takes only three values. If you see, these loops only take three values, and it will tell me first whether it is possible, right? If is possible to take step, okay. If it is possible to take a step, then only it will take, okay. Otherwise it is not. What do I mean by is possible? So you need to check whether it is in the upper triangular matrix and whether it is not going out of the grid, okay. It should not go out of the grid. So I will just write a bool is possible function. Okay, so it has nothing but x, y, and n also. So all I need to do is make sure that it lies in the where it does lies. Make sure it lies in upper triangular matrix. Upper triangular matrix. Okay, so that is what you need to make sure exactly. So if y needs to be greater than x here, first of all, y needs to be much greater than x, much not like just greater than x, okay, and they must also be within the grids, okay. So x should be greater than equal to 0, and x should be less than n, and y should be greater than equals to 0, and y should also be less than n. All of these criteria, if it satisfies simultaneously, then only we will return true. Then only it means that it lies in the upper triangular matrix. Otherwise we will just return false. And here I am asking that if it is possible to take a step, then you update your dp, okay. So now dp of xy, okay. So what does dp of xy contain? It will definitely contain maximum of dpxy. So you can go to the maximum of you update it only if you are getting a new value which is maximum. So how can you get a new value? It is given by this uh, fruits of xy, okay. So it just takes the fruits of xy plus dp of ij, okay. So I hope you understand this. You are currently in the I and J, and from there you want to take a step to I minus 1. Okay, to I minus 1 row. J has three values. You can take any step. Okay, and when you take a step, you want to add some fruits. Okay, you want to add the fruits which are already present at x comma y. Okay, and you want to just maximize things. You just want to maximize things. So you just take this maximum value, and what do you do now? What do you do now? You need to have some edge cases here also. But let's try to tell that what you need to do. So where you just need to return something like fruits of. Tell me if you do not understand. Okay, you just tell me if you do not understand. So you need to do something like dp of, not dp. You can call fruits also dp also, whatever, n minus 1 plus maximum among dp of uh, this 1 and n n minus 2 and dp of 1 n minus 1. Okay, it is, yeah, and it will be n minus 1. So did you understand this? What did I do here? What did I do here? So I just did nothing. I just did nothing. I will just tell you in short what did I do. I just reached this point. Okay, I just finished reaching these points. I just finished calculating. So this is my diagonal. I just finished calculating all these roads. Okay, and I want to take. I have this. I am currently in this, right. So I have two choices to take here or here in these two paths only. So I take the maximum among these two values. Okay. So this is, if this is 0 comma n minus 1. Okay. This is nothing but 1 comma n minus 2 and 1 comma n minus 1. These two are grids are nothing like this. Okay, so you just take the maximum of these two and add the value with this. Okay, I just stopped my iteration over here because from here I just have two choices, so not three choices anymore. So I just take something like minimum of 1 n minus 1 and 1 n minus 2. But you can easily understand that if there would be errors, if n is something like 3, if n is 3 or n is 2. So if you see, if you put n equal to 2 here, you will end up in getting dp1 0, which will cross the diagonal. And if you put even 3 here, you will end up in taking dp1 1. Okay, you will end up in taking dp1 1, which will also cross the diagonal. So you just write the base cases separately for 1 and 2 and 3. So if n is equals to 2, then what you need to return? You need to return simply the roots of 0 comma n minus 1. Okay, and just return the top value. And if n is equal to 2, you just return whatever is the case. You can write dp is fruit, right? So for a smaller representation, you can just write dp and you just add these elements. Okay, so you just add 0 n minus 1 with something like dp1 n minus 1. So I hope you get this right for for grid of size 2 and grid of size 3. So if you have a grid of size 2, this is the only square which you need to add. And if you have a grid of size 3, okay, these two squares are the only things which you need to add. So for a grid of size 3, I am adding 2 squares. Okay, and for grid of size 2, I am adding just 1 square. And that's all I guess. So you see, I will, as I told you, I will just add this to my answer. So I will just add this max score of roots to my answer. But I also need to transpose the matrix, as I had already told you that if you are able to solve for this guy, okay, you just take a transpose of the matrix. You just take a transpose of all the values, and you can also solve for this guy in a very similar manner, right? So what you can do is that you can just take a transpose. So for I equals to 1 to n, and for j to be something like I plus 1 to j less than n, you can just take a transpose. That is, you can swap the values. You can just swap the values of fruits ij with fruits ji. I hope you already know what transpose means. And you just add to this answer the max cure value. Okay, you just do the same things again, because that will apply for the bottom left guy also. And you can just simply return answer, and that will be our solution to this problem. So let's try to run it and check. You see, we do have the accepted thing. If we try to submit it, we should also get the accepted if I have not done something wrong. So yeah, we do have the accepted case, and we have an okay runtime complexity. So I will also add this to my DP playlist because it is a very good and important question for DP on grids. Okay, and so yeah, that's all. That's all for this problem. I hope your day goes very easy. Thank you so much.